Okay, in this video, I'm going to go through the homework problem on the low-shoe magic square tester. Okay, so the problem defines a low-shoe magic square as a 3x3 matrix. Okay, we're going to use a two-dimensional list where each numeral 1 through 9 is used exactly one time, and that the row columns and the the row totals and the column totals are the same. Okay, correct? Yeah, I think that's it. Does it also do the diagonals? I don't think it does. Let me double check. It's good to read the program before you program it. Okay, right there. Oh, it does do the diagonal also, the main diagonals. Okay. So I'm not testing diagonals in the version that I've done, but we'll see how that goes. Okay, so to get this one started, we're going to have our main function as always. Go ahead and make sure that we call it at some point, so it won't do nothing. Okay, and we can go through and set up, and I'm going to set up the one the book says is a magic square. Okay, that's 4, 2, 9. And then it is a 3, 5, 7. And then it is a 8, 1, 6. Okay. So we have that one going. Okay. And then I'm going to create this low shoe that I'm going to send that to. Okay. This low shoe function. And that's going to be a Boolean function. So I guess I can go ahead and say if low shoe A print this is a low shoe magic square, else something's unhappy with the indentations. There we go. Else print. Okay, something's funky there too. Don't know what happened there. It'll tell me if it's an issue though. Print this is not a low shoe magic square. Okay, so that's what the function is going to do. Okay, so we're going to start our function here. We'll take in whatever we're going to call our matrix. Okay, and the first thing we're going to do here, just to make sure that we don't make any changes, is I'm going to take the precaution of making a copy. We'll deal with the copy. Okay. So a couple of things we have to worry about. The first thing we have to worry that every numeral is used just once and that every numeral is between 1 and 9. Okay. So I think the easiest way to do this, and this is a technique we haven't done before, but I think it's one that makes sense. Okay. I'm going to create a list of the range from 1 to 10. Okay, so this is going to be all of the items that should be in the list, right? So I'm going to have a list. So again, if you want to test this, if I copy this here and paste it over there, and then I look at n, okay, n is going to be the correct numerals for the square, right? It's going to be the 1 through the 9, okay? So that should be good. So the idea is then as I go through the list, if I see a 1, I'm going to remove it. If I see a 5, I'm going to remove it, okay? If I can't remove it, it either means I've already removed it or it's outside of the range, okay? So again, as an example over here. So let's say the first number is a 4, okay? So I can do an n.remove 4, okay? So now the 4 is gone, okay? If I were to see that another 4 somewhere in the list, you get the value error, Okay, so I'll be able to check for that value error. It's the only way I should get a value error in this program, so I'll know that's what caused it. Okay, that either, okay, the other thing is if I do an n.remove some other number, 11, okay, also, what didn't it like about that? Oh, I did it the wrong way. N.remove 11. It's also going to give me the value error. Okay, so if it's not a 1 through 9, or if it's been used more than once. Okay, so I'm going to use that concept here. And again, I need to iterate through the list. Okay, so I'm doing for R in range 3. Okay, I'm going to do a for C in range 3. Go through all of them. Okay, and then I'm going to say n.remove B sub R sub C. Okay. And if that's trouble, that is going to cause a value error. Okay. So I can go back here. Well, I can just test it. Okay. If I run it now, it should be okay. Okay. And it says it's not because there's no reason for it to be true. We haven't tested it yet. But if I have, let's say, a 10 here and run it, it's going to give me a value error. Okay. Or let's say I use a 2 twice. It's also giving out a value error. Okay. But when I run it correctly, again, it does not give me a value error. Okay. So I can take all of this, tab it over, put it in a try block, and I can have an accept value error. If I see this, then I can print is out of range or is repeated. Better way to do that, but anyway, that's going to catch that error. Okay. So the next things I need to worry about, calculating the row totals to make sure they're all the same. Okay. So I'm already going through in a row first fashion here. So I should be able to go ahead and check the row totals here. Okay. So I'm going to, I mean, I can just do this again, but in fact, let's keep it separate. Okay. So this, I'm going to check proper numerals. Okay. Here I'm going to check for row totals, okay, or calculate row totals. Okay. So I do this again. I'm going to do a for R in range 3. And a for C in range 3 as well, for 3 by 3. Okay. And I want to make sure that I'm gonna keep my results in another list. Okay, so I'm going to call that R total is equal to an empty list, and then I'm going to go ahead and append the values to it as we go. Okay. So as I go through this, every time I get to a new row, so here's a new row, I'm going to set this S variable equal to 0, or I'm going to sum them up. Okay. And then inside of each of these, I can say S is equal to S plus the current value. Okay. So for the first row, it sets S to 0, and then it's going to add the 2, the 4, and the 9. Okay. Then it's done. Okay. So when it's done, that's where my cursor's at. When it's done, I can do the R total dot append S. Okay. So then let's go ahead and print R total just to see what's happening. Okay, see if this is working so far. Okay, see if we're getting those row totals. Okay, so let me run this. And we get 15, 15, 15, which is correct. Okay, so if you add up the 4 plus the 2 plus the 9 and the 3, 5, 7 and the 8, 1, 6, those are all 15. Okay, so now we're going to go through, I'm going to copy this because it's going to be very similar, to calculate the column totals. Okay, so the column totals it's going to be a C total. Okay, but this time I'm going to have to do the C on the outside and the R on the inside. Okay, so instead of going this way, it's going this way. Okay, otherwise it should be the same. I'm still setting S equal to 0 on each new column. Okay, and then inside of the rows and columns, I'm appending, but I need to append that to C. Okay, it's still row and column. They're just going in a different order. Okay, but it's still the same order as far as how you display them. Okay, then we display our C total. Print C total. Okay, so for this one, that should be all 15s as well. Let's see. Oh, it's not. This must be the one that's wrong. Let's see. That should be 8, 9, 10, 11, 12, 13, 14, 15. It is. This should be 5, 6, 7, 8. Yeah, it's the 9. 2 is the one that is correct, I think. So let's see. Yes. Okay, so we've got that. So we're good on those. Okay, so we don't need to print these totals. We're pretty sure they're looking okay, but we now need to check the totals. Oh, the other thing we have to worry about, I didn't do, but let's do it. I like to preview the complex ones. Okay, I want to calculate diagonal totals. Okay, so if we're looking at this, we want to go 0, 0 plus 0, 1 plus 0, 2. Okay, so we're only going to have 1, 4. Okay, so for R in range 3, okay, we're going to get a new S here. So what do I want to do here? How do I do this? Not going to do. Let's call this D1 for diagonal 1. It's going to be equal to D1. I'm going to set equal to 0 plus I'm going from 0, 0. Oh no, I do need 2 rows. Okay, let me. This clear. Again, I want to go. I'm just going to. I tell you, you know what I'm going to do here? I'm just going to do this way. I don't need a loop. A loop that's going to confuse me. I want B sub 0, 0 plus B sub 1, 1 plus B sub 2 2. Right? I want B sub 0, 0, 1, 1, 2, 2. Okay. So for the other one, I want 0, 2 0, 2, still 1, 1. And then 2, 0. Okay, I've got this right. Okay. So there's 3 of those. There's not, the loop would have been super confusing. So we'll do that. Okay. So now what I have to do, I need to make sure test that all are the same. Okay. So I'm going to do a target equal to D1. Okay. And let's make sure this is correct. Let's go ahead and print out D1 and D2. Okay. And that's 15 and 15. So those are correct. Okay. So everything should be equal to 15. Okay. And it is. If we can look, we can see all of our row titles. But I'm going to let my target be equal to that. Okay. So then if D2, actually I can start here and say if D1 does not equal D2, we're done. Return false. Doesn't work. Okay. Now I'm going to test the row and columns. Okay. So to test those, to make sure the target's correct. Okay. So I now have two different one-dimensional lists. Okay. So I only have to worry about one variable. Okay. So I can say here for X in range 3. Okay, so I'm going to go through each of the values. Then if my R total at that position is not equal to the target, 15 in this case, or if my C total at that position is not equal to the target. In either case, I'm going to return a false. Okay. If not, when I'm done with all that, so I have to come back up to there. Only then am I going to return true. Okay. So again, this is going to test that diagonals are the same. Okay. Then if any of that's false, it's going to return this. If not, it's going to return true. Okay. So that should test everything out, right? That should make sure things are good. So let's try it and see. If I do this, I may have a print I don't need, but no, worked. This is a low shoe magic square. Okay. So now we can go back and make it not be 1. Okay. So if I make it a 2, 9, it will not be 1. And if you run it, it will say this is not a low shoe magic square. Okay. So that should do it, right? That should be everything we need. Again, just to go through it, we're starting off here. It didn't say to allow them to enter it. Okay. We're just going to assume there's one there. You could do that if you wanted. Okay. But then we're going to say this low shoe function is going to be a Boolean. Okay. So I can go ahead and put in my preconditions. A is a 2-dimensional list. Okay. And I could test this. I could say if is instance A should be a list. So if not, that I'm going to return false. Also, if not is instance a 0 should also be a list. That's how we get the 2-dimension. I'm again going to return false. Okay. And then and A is not changed. So this is where we're getting that A not being changed. Okay. So the post conditions then are that, go ahead and put that up here. Sometimes you need to check it later. In this case, we're not going to do that. Post conditions, true, return true if a low shoe square, false if not. Okay. Okay, so that's our preconditions, postconditions. Again, we're checking to make sure that A is a list, and since it's two-dimensional, A0 is right there, should also be a list. Okay, we could check for the length. So I could say here, if not is instance a list, or the length of A not equal to 3. And then here I could say this, or the length of A 0 not equal to 3. That should cover that as well. That should cover all the possibilities here. That it's a 3 by 3. Okay, make sure that actually runs and doesn't give me trouble. Okay, that's the one that's not, so but it didn't give me any other issues. So let's make that the 9 and that the 2. Oh, I hit a random character by mistake. I don't know what that just did. That's super weird. It didn't cause other issues. Try that. Yeah, this is a Lewisian magic square. So we got that. Okay, again, so we're that it's a 3 by 3 two-dimensional list, and A is not changed. Okay, so that's where we're making sure that it is that A is a list and A0 is a list, and that the length of A is 3 and the length of A0 is 3. Okay, it's possible one of the others could not have that, but I'm not going to test that much. I think this looks good enough to me. Okay. Then we're going to make our copy here, and then we're going to get our list of numbers to make sure we have all the right numerals. So we're going to go through the list and remove all the numerals that are there from this list, 1 up to 9. So if it's not here, it's either because it's already been done before, which is a violation, or it's bigger than 9 or smaller than 1. That's going to take care of that. We're then going to go through row column to calculate the totals for those each row, okay, and put that into a list. Do the same thing column by column, put that into a list, okay. We're then going to just hard code the diagonals. We're making sure the diagonals are the same. If not, we're going to return false. And then we're making sure that everything else, okay, is equal. So we're making a target out of this first diagonal. We're going to go through and make sure that the R total in the 0th position is equal to that, and the C total 0th position is equal to that. And then we're going to do for the same thing for the 1 and for the 2. So they're all going to be equal to the same value. Okay. If any of that's not right, it's going to return false. If it gets it to here, everything's okay, and we return true. Okay. So that's it. That was a complicated program. Okay. But again, hopefully by watching the video, you'll see that I'm taking it step by step, and I'm going, get one thing working, then one other thing working, and kind of go from there. Okay. If you have any questions on this, make sure that you let me know.